Modern LLM development has prioritized consistent gains in reasoning and logic. However, as these capabilities mature, engineering efforts are increasingly directed towards reducing the physical latency of the response itself. OpenAI's new $100 per month Pro plan sits at 5 times the cost of the standard Plus tier. This pricing structure marks a departure from the simple consumer models that defined the first 3 years of the platform. The tier is built for developers. It offers 5 times more capacity for Codex than the $20 Plus plan, specifically to support users who require high-intensity output during active coding sessions. As this new tier arrives, OpenAI is retiring the legacy 5.2 model. The company is now maintaining 2 distinct development paths for its software. The standard ecosystem is being refined for human conversational tone and safety, while this high-end tier is being rebuilt for the speeds required by automated machines. OpenAI's technical reports indicate that the model powering this premium tier performs worse on standard software engineering benchmarks than the primary Codex model. This performance gap is a deliberate choice in the model's design. The $100 subscription provides access to a dual-mode compute architecture, where the priority is no longer just the quality of the answer, but the speed at which it is delivered. For the general user base, GPT-5.3 Instant has replaced the older models as the default conversational interface. The engineering focus for this model was on tone and usability. It is designed to be more direct, leading with answers rather than the lengthy safety disclaimers and refusals common in earlier versions. This data shows how GPT-5.3 Instant has reduced hallucination rates compared to its predecessor, GPT-5.2. When using web search to verify information, the hallucination rate dropped by 26.8%. In specialized fields like medicine, errors based on internal knowledge fell by 19.7%. The model now handles requests that fall near safety boundaries with fewer unnecessary refusals, attempting to provide helpful answers without breaching existing guardrails. While these refinements make 5.3 Instant a more fluid conversationalist, its architecture is not designed for the sustained, high-speed iteration required by modern software engineering. In automated coding, the 2 primary constraints are time to first token and the overall tokens per second. Standard API infrastructure creates a severe bottleneck. Each time a user sends a prompt, the system must establish a new connection, adding a delay that interrupts real-time collaboration. This diagram illustrates the standard request-response cycle. OpenAI restructured this inference stack to remove the friction of repeated connection attempts. By implementing a persistent WebSocket connection, the system maintains a single, open channel between the client and the server. This change reduced the overhead of the client-server round trip by 80%. The team also optimized the individual data packets, cutting the per-token overhead by an additional 30%. Combined, these software changes cut the delay before the model begins its response by exactly half. Rewriting the software layer addresses the network limits, but achieving a sustained output of over 1,000 tokens per second requires a change in the physical hardware.
Traditional GPUs are effective for large-scale training, but they face physical limitations when serving tokens instantaneously due to the way memory is distributed across multiple separate chips. This silicon wafer is part of OpenAI's partnership with Cerebras. It is designed to move data much faster than a standard cluster of individual processors. This is the Wafer Scale Engine 3. It is a single, massive accelerator built specifically to handle high-speed inference tasks. By running on this monolithic hardware, Codex Spark can deliver more than 1,000 tokens per second. GPT 5.3 Codex Spark is the specific model designed to utilize this Cerebras hardware. To maintain these speeds, Spark is a text-only model with a 128,000 token context window, stripped of the multimodal features found in the more general GPT 5.3 models. It is programmed for a lightweight style, focusing on making small, targeted edits to code, rather than attempting to rewrite large blocks of logic. The $100 Pro tier effectively rents time on this specialized silicon, providing developers with a tool that is responsive enough for live iteration. This focus on speed creates a contradiction. Codex Spark is the flagship developer tool, yet it scores lower on many coding evaluations than the models that cost less to use. This plot uses SWEM Bench Pro to evaluate models, comparing time taken against accuracy. Standard GPT 5.3 Codex provides high accuracy, but takes minutes per solution. Codex Spark plots lower on accuracy, but far to the left, completing tasks in a fraction of the time. Spark is optimized to deliver an answer nearly instantly, even if that answer is less likely to be perfect on the first attempt. Developers often find that waiting minutes for a highly accurate model interrupts their workflow. A model that responds instantly allows the human operator to catch errors and redirect the AI without losing momentum. For those working in live environments, the ability to iterate 3 or 4 times in the time it takes a smarter model to respond once provides more practical utility. In the context of real-time software development, low latency has become a more critical feature than single-shot accuracy. The $100 Pro plan is designed to facilitate a dual-mode workflow that utilizes both ends of this performance spectrum. In this system, heavy, high-reasoning models run in the background to solve complex architectural problems over the course of hours or days. Simultaneously, Codex Spark runs in the foreground on Cerebrus hardware, providing the developer with an instantaneous stream of code for immediate parallel iteration. This strategy is OpenAI's primary response to competitors like Anthropic, whose Claude Code plan also targets this high-end $100 monthly price point. For developers who require AI to be embedded directly into their work environments, the standard turn-based chat is being replaced by these integrated, low-latency execution tools. Advancing AI utility now depends as much on the physical design of the hardware as it does on the size of the neural network. Subscribe to the channel to see how these high-speed developer workflows are changing the way software is built.